Assalamualaikum. My name is Muhammad Irfan Rafiq. My matric number is 215852. So today I'm going to explain about this program. For our assignment, we're using simple ASM or SASM. So this program has been given by Dr. Khairul Nizam. So now I will explain how the program work and what it do. So first, I built this program. Okay, is that on log is that will successful, and then I will press debug here. Is that debugging start. So after our program boot successful, we started the debugging, and we will come out here the memory variable expression value and type. So we add the variable data, then result. So here we change it to hexadecimal. And here is W. And then for the error size for data is for result is 1. Alright. Okay, so after we done fill up our memory, so we can check here our register at the right side here. Okay, so this is register that we can check. So after that, I'm going to step through the program. So we use the step over. So for the line, okay, for the line 6 is that move move EBP ESP correct debugging. Alright, so move. So this is a move current state position into EBP, which is base of the stack. So from this, we now have reference points that allow us to reference our local variable. Or variable our it's allow us to store our local variable on the stack. Yeah. So let's let's step through the program. I use F10 for the shortcut. Um, Before that, we need to know that every time I step over or step through the program, like press F10 for the shortcut, the register here will change, right? So I press F10, step over, and then for the line 7 here, set subs EAX, subtract EAX. So it clear the register on AX. So we see here the register EAX is that state that 0x1. Okay, after I step through the program, step over it, then it will clear the register on on AX. So it's 0 here. Okay, next at line 8, move ECX 0x04. So is that here we need that here set the counter to 4. So EXX here we see is just the number here. So after I step over it, it will change the ESX to 4 because it's the ESX counter to 4. So we see here ECX4. For your information, this is what I think. I thought. I thought. I think. Set counter to 4 is actually is a loop segment. It's actually basically how many times you want it to loop. If we set here 5, set counter to 5 or 6, it will loop 6 5 times. So Dr. Kairizam given set counter to 4, so it will loop. I'm sorry, so it will loops 4 times. Okay. So after that, at line 9, move ESI. So we set so here we'll set the offset to add. See ESI, where ESI? Here ESI is when I press F10, step over it, it will change the ESI to add. So the set counter to 4, right? Okay. And then for the loop segment, yeah, it's decrement. It will decrease. Alright. So it decrease ESI. Our ESI we said that is 8, right? So it will decrease by 1. So if I step over it, it's become 7. It decrement by 1. Right? And then I step over it again. It decrement by 1 again. So 6. And for the line 14, it will add AX. That's it, data plus ESI. Data plus ESI. So when we plus the data and ESI, the result will come here. So it will add the number to register AX. We step over it. We get through step through the program. Here it will become 16384. Right. So the data plus ESI will become 16384 here. So the loop function is we will loop the function 4 times because we set it to 4, right? So and then we press the step over again. We will decrement again 3 because because we set it 4 times. So the loops now have 3 time left. So we decrement before this 7, right? So it decrement before this, my bad, before this 6. So when I press the step through step over, it will be decrement by 5. Okay. So we added the data and ESI become 28672. So why it become 4 because we decrease SI by 1. 6 before this 6, 5, 6 apa? 7 and decrement by 1, 6, decrease again by 1, 5, 5 my bad. Before this 7, decrease by 1, 6. Okay, 6 and then I step through the program, decrease by 1 is 5 and then I should step through the program again, decrease by 1, 4. Right. So it keep looping until till finish. So after the sum up here, the register access now become 28672. There's the ESS now has two loops left. Okay. So our ASI now 4 and then I will step over. It becomes 3. I step over again, it decreases to 2. Alright, so it will add again to the register AX. So here 28672, I step over it, it become 36864. Alright, so our loops now is to left. Then we loop again. We loop again now. Loop again and do the same thing. Decrease by 1. Now it's 1 and decrease again. Now 0. And then the data plus ESI and then the register will go to AX. I'm sorry. Before this, before this we add the data, right? Before we loop in, we add the data. So the data change 36864. Okay. So we loop again and decrease by 1, and we add again. It will come out here. The result 40960. And now our loop is one time left. Then we'll jump because the looping is now done. We will jump to here to line 18. Because start here keep looping until CX0. So our CX now 0. Alright. So we'll jump here. Line 18 subtract EDX. So our EDX now 1 to 8, right? So if I step over it, it will clear the register ADX. So it becomes 0. So our EAX is 409610. I'm sorry, 60. Okay, so here the line 19 is that move CX. So we set it divide to 4 data. Alright. So CX we set it to divide to 4. So you want to divide the data to 4, and then divide the data to 4, and then after we divide it, it's at 40960 divided by 4, it will become 10240, 10,240. Okay, so after we divide it, the line 21 state that the result is stored into the data. Alright, so step through the program, the data here, store it here. Alright, so we step through again, and for this function, okay, we go to this function, print hex. Print hex actually location point by result. We can see here on the help menu, print hex. Print hex is a print hexadecimal. It's a similarity preview, but data is printed in hexadecimal representation. Okay, so it come will come out the result on hexadecimal on output. Okay, so when we step through it here, the result will come out here on the output, 2800. Because why is 2800? Because hexadecimal. So the hexadecimal is 0x2800. So here is 2800. Because why the output become, why not the output info or any type? Because we set here in the memory we want hex. When it's not binary, or when it's not, because we want hexadecimal. So it's output the hexa is result. The result is hexadecimal 2800. Okay, next we step through the program again. So move ex before that move ex 0x1. Right. So the before the data from that has been stored is set to be 1, because the system call to exit data. And then for line 25, we introduce 0x at t. So call kernel. So the kernel is called to call kernel mean the kernel is called to handle the interrupt it actually performs cleanup task. So we clean up the task, and so the debugging is finished. So let me try debug again. Step over. Alright. So debugging is finished. So that is how the program work, and how we want to print out the result to the output, and that's it. Thank you for listening or watching to my explanation about this program, and I hope Dr. Khairul justify of what I'm trying to explain here, and trying to show how the program works. Thank you.